Okay, so today we are working on addition rule of probability. There are two parts in this rule. The first part is for the mutually exclusive or disjoint events. When I say mutually exclusive or disjoint events, these are the probability events that cannot occur at the same time. So they are called the disjoint events. Um, There is a special formula for calculating the probability of the disjoint event, that is probability of A or B is equal to probability of A plus probability of B. Make sure you write this formula. We use the addition rule when we see the word or between two events. So two events A and B, they are disjoint or mutually exclusive when there is nothing common between those two, or the occurrence of one event does not affect the occurrence of the second, or we can say that the events are disjoint when they cannot occur at the same time. So once we have this formula, what we are going to do is we are going to use this formula to solve a problem and see how we can use the addition rule for probability. Okay, so this is my example. Let's read the problem first and find out what is given. A bag contains 16 white marbles, 3 red marbles, 9 blue marbles, and 7 yellow marbles. So that is what you have in the bag. So if you want to find the total number of marbles in the bag, what is the total number of marbles equal to? It is 16 plus 3 plus 9 plus 7, right? What is that equal to? Please add in your calculator and tell me what you'll get. 16 plus 3
35.
plus 9 plus 7. What is that?
35.
35. Very good. So you have a total of 35 marbles there. Now the question is, if a marble is drawn at random from the bag, so you're not looking at the bag, you're just putting the hand in there and you're pulling a marble, we have to find the probability that it is a yellow marble or a white marble. So we are looking for the probability that it is yellow or white. So you can see here, you are randomly selecting a marble, that's one marble. And when you pull that one marble, you'll not get both yellow and white. Meaning of that is yellow and white, they are not going to happen at the same time. So these are disjoint events. They do not occur at the same time. They are mutually exclusive event. And there is or in the middle. So we use the addition rule of probability 1, which is equal to probability of yellow plus probability of white. So that was the formula. Now, if you want to find the probability of yellow marble, you can see there are 7 yellow marbles out of 35. So that will be 7 divided by 35 plus probability of white marbles. You have 16 white marbles out of 35. So it will be 16 over 35. Now, we can add those two. You have a common denominator. So you can add the numerator, which is 7 plus 16, which is 23. So you'll get 23 over 35. That is the answer as a reduced fraction, but you can change this to decimal. So when you change this to decimal, you can just divide 23 by 35, and you'll see that you'll get approximately how much? Do it in your calculator. Did you get that? 0.6571?
Yep.
Okay, so that is the probability, and always verify that as you're calculating the probability, these number, the answer after you calculate the probability, it must be between 0 and 1, which is between 0 and 1, so we got that right. So we use the addition rule for probability for mutually exclusive event, and here we have two events, probability of occurring yellow or white. Now let's look at the second part. In the second part, we are asked to find if a marble is drawn at random from the bag, find the probability that it's a red, blue, or yellow marble. So you have three events here. Probability that it is a red, blue, or yellow. You have or in the middle, so definitely you are going to use the addition rule. But when you're picking a single marble, it cannot be red, blue, or yellow at the same time. It can be red, or it can be blue, or it can be yellow. So the events are disjoint. They are mutually exclusive. So we use the addition rule for probability. But here we have three events, so it will be the sum of these three probabilities. So it will be probability of red plus probability of blue plus probability of yellow. Then we are going to find the individual probability. Probability of red, you can see you have three red marbles out of 35. So that will be 3 divided by 35 plus the probability of blue marbles. You have 9 blue marbles out of 35. So 9 divided by 35. Then plus yellow marble, you have 7 out of 35. So 7 divided by 35. Now you have the common denominator. So you can add the numerator. 7 plus 9 plus 3, that is equal to how much? Is it 19? Right?
Yes.
19 over 35. So that is already a reduced fraction. You can read the answer like this. Or if you change it to decimal, you can divide 19 by 35 in your calculator. And what did you get? Tell me.
0.5429.
0.5429. Very good. So that is the probability of the occurrence of red or blue or yellow marble. So in this example, what we did is we used the addition rule for probability. And in the addition rule for probability, we use the first rule, that is for the mutually exclusive or disjoint events. Any question in this example? I want you to speak up, unmute yourself, and just say whether you understand or not.
No.
No.
You didn't get it?
Yeah, this person. Okay.
That's good. Okay, great. Okay,
Yeah.
let's move forward then. Now we have the second addition rule for probability, and this is for non-mutually exclusive or joint event. Now you can see that the probability of occurrence of A and B, there is something common there. So when we say non-mutually exclusive or joint event, meaning of that is these are the probability events that occurs at the same time. So the occurrence of two events can happen at the same time. So the formula will be a little bit different. As we are working on addition rule, you will still see or, but there is a common reason between A and B. If this is your event A and this is your event B, the common reason that is shared by A and B, this is called A, that's B suppose. This is called A and B. The common reason is A and B. So the formula will be probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So if the events can occur at the same time, we use this formula as the addition rule for probability. Make sure you copy this formula because in next example, we are going to use this formula and solve the problem. So probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So always remember here, when you compare these two rules, when we have mutually exclusive event, we don't have this part. We don't have probability of A and B. This is not there. Meaning of that is this part will be 0 in that case. But if the events are mutually, non-mutually exclusive or they are joint, then this has some value. That's why this occurs here in the formula. Let's take an example. Okay, here is the example. One more time with the cards. And I have the same list of cards from the previous class. You can see there. Let's read the problem. A card is drawn at random from a well-shuffled deck of 52 cards. Total card will be 52. That's why I said 52 cards. Find the probability that it is either an 8 or diamond. So the problem here is we have to find the probability that it is an 8 or diamond. Now, let's think on this. When you are pulling a card from here, if it happens to be 8, do you think that it can also be a diamond? Yes or no?
Yes, it could be.
Yes, there is an 8 of diamond, right? There is an 8 of diamond. That's why it can be the 8 and also diamond at the same time. Or if you think the other way around, if you pull a card and if the card is a diamond, do you think that it can be 8 also?
Yes.
Yes. So that means these two events can occur at the same time. We are looking at or, so we are using the addition rule, but these two can occur at the same time. So we need to use the formula with that minus at the end. So this will be probability of 8 plus probability of diamond minus probability of 8 and also that is a diamond. So let's write these probabilities. Let's find these probabilities. Probability that it's an 8. How many 8s are here in the set of cards? Look at that. How many 8s are there? How many 8s are there in all? 4, right? 4 out of 52. Very good. 4 out of 52. Plus, how many diamonds are there in all? In a set of cards or in a deck of cards, how many diamonds will be there? If you know, you can just tell it. Otherwise, you
13.
can count here. How many are there? How many?
13.
13 out of 52. Very good. Minus. Now, how many cards are 8 and diamond both? How many cards are 8
1.
and diamond both? 1, right?
1.
It's just that card. 1 out of 52. 1 out of 52. So you have a common denominator of 52. So in the denominator, you can write 52. But in the numerator, you have 4 plus 13, which is 17, minus 1 is 16. 16 over 52. That is the probability, but that's not the reduced fraction. You may want to reduce that by dividing both numerator and denominator by 4. So if you do that, it will be 4 over 13. If you reduce this will be 4 over 13 because you can divide both numerator and denominator by 4. 4 times 4 is 16. If you divide this by 4, and if you divide this by 4, you'll get 13. So 4 over 13 is the answer. You can leave it as a fraction like this, or you can change it to decimal. That is, you can divide 4 by 13. Please divide that in your calculator and you should see 0.3077. That is a probability that it is either an 8 or diamond. Any question in the first part? Yes, no?
No. Nope.
On that. Okay. Let's work on B then. Let's find out what is there in B. In B, we have to find the probability that it is either a raid or a king. So we have to find the probability that it is a raid card or a king. Now, as soon as you see this or, you know that you are using the addition rule. But you have to check here whether you are using the first addition rule or second. The first one is mutually exclusive, which has the probability of R plus K only. The second one has minus the probability of R and K. So the way you check is, do you think that when you pull a card from here, and if it is a raid card, do you think that it can be a king? You pull a raid card. In your hand, you have a raid card. Do you think that your raid card can be a king? Yes or no?
Yes.
Okay. And then if you think the other way around, suppose in your hand you have a king. Do you think that that king can be red in color?
Yes.
Yes, that means these two events, they can occur at the same time. So these are not disjoint, these are joint or non-mutually exclusive. So the formula will be probability of R plus probability of K minus probability of R and K. Now let's write the values. Rate cards. So probability of rate, we have 26 rate cards. So it is 26 out of 52. 26 out of 52 plus king. You have, if you look here, you have 4 kings. So 4 out of 52 minus card, which is both raid and king. So these two cards, these are raid and also they are king. So you have 2 out of 52. 2 out of 52. Remember one thing, in the exam, you don't see this list, but you should know these cards, or you can print and keep this with you so that you can just look at them. Okay, now let's simplify this and let's find out what we'll get. So you have the common denominator, no doubt on that. 52 in the denominator. In the numerator, you have 26 plus 4, which is 30. 30 minus 2 is 28. Now you can reduce this. You can divide this by 4 and you'll get 7. You can divide this by 4 and you'll get 13. 4 over 13. So you can leave your answer there, or you can divide 4 by 13 and you can write that as a decimal, which is 0.3077. That is the probability. So in this example, we use the addition rule of probability for non-mutually exclusive or joint events. So when we say non-mutually exclusive events, these are the events where the possibility of occurrence of both is there. Okay.
7 divided by 13 is.
Yeah, I got 7 divided by 13 is 0.5384 or 85.
7 divided by 13. Let me do that. 7 divided by 13. Maybe I did 4 divided by 13. That is why. You people are beautiful. Very good. Yes. So it is 0. You said 5385, right?
Yep.
Yes.
Wonderful. Thank you for making that comment there. That's right. Instead of dividing 7 by 13, I did 4 by 13 in my calculator and I make a mistake. So you are there watching at me, which is good. Thank you. Okay. Here is what we have learned so far. See, we did 2 formulas for or in the addition rule. The first one is probability of A or B is probability of A plus probability of B when 2 events are mutually exclusive, and when 2 events are non-mutually exclusive, we saw that the probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So meaning of that is, if you want to check whether 2 events are mutually exclusive or not, in mutually exclusive event, we don't have this part. We don't have minus probability of A and B. The reason why it is not there is because this probability will be 0. That's why it is not there. So if you are asked to check whether 2 events are mutually exclusive or not, you have to check whether this probability is 0 or not. If this probability is equal to 0, the events are mutually exclusive. If this probability is not equal to 0, then they are non-mutually exclusive. So always remember, for the mutually exclusive event, probability of A and B must be 0. Let's take an example and verify these events. Okay, here is that. For sample space S, this is the sample space. For sample space S, let A equal to 1, 2, 3, 4, 5, B equal to 4, 5, 6, 7, 8, and C equal to 7, 9. If you want, you can also draw this. Can you hear me?
Happens.
Yeah. Okay, we are working on this problem, I think. We say that two events A and B are mutually exclusive if probability of A and B is 0. And for this example, they have given the sample space S, and then, I don't know, what is that red line coming from? Okay, so the sample space is given. They have given the event A, B, and C. If you want, you can represent this using a Venn diagram. So in the Venn diagram, normally what we do is, you can draw this. We represent the sample space with a rectangle. We draw a rectangle and we represent the sample space. This is your S, the sample space. Now there are three events, A, B, C. Your A is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So suppose this is your event A. Okay, that is event A. There is event B, which is 4, 5, 6, 7, 8. And you can see in A and B, we have a common element 4 and 5. Do you see that? In A and B, there is the common element 4 and 5. Okay. In A, you have 1, 2, 3, 4, 5. So here you have already 4 and 5. So you'll have 1, 2, 3 here. Okay, 1, 2, 3 will be here. So 1, 2, 3, 4, 5. And in B, you have 4, 5, then 6, 7, 8. 6, 7, 8 will be here. So 6, 7, 8, they will be there. That's A and B. Now, there is another event C. C has 7 and 9. You don't have 7 here, but you have a 7 there. So let me write it a little beautifully. Give me a second here. 6, 7, 8. So 7, which is here, is also there in C. So if I draw C like this, C shares 7 with B. Then it has 7 and 9. That's what I can do. Now let's find out what is missing. We have all elements from 1 through 10. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is missing, so 10 should be outside of this. So this is how you can represent using Venn diagram. So after we represent with Venn diagram, let's answer this question. Are the events A and B mutually exclusive? So if you want to check whether they are mutually exclusive or not, we have to find the probability. So what is the probability of A and B? Probability of A and B. Let's see whether it is 0 or not. So how many elements are common between A and B? If you look at A and B, how many elements are common? Just look at that.
2.
2 elements are common out of 10. So 2 out of 10, which is equal to 1/5. So you can see that the probability of A and B is not equal to 0. If A and B, okay, A and B are mutually exclusive if probability of A and B is 0. But here it is not equal to 0. It is not equal to 0. So are these mutually exclusive?
No.
No. Okay. They are not mutually exclusive. They are not mutually exclusive. They are not mutually exclusive. Okay. You got that. But what we said earlier was mutually exclusive means they are joint, and definitely A and B are joint here, right? So mutually exclusive means they are disjoint, but here they are joint. That's why they are not mutually exclusive. Any question on part A?
No.
Okay, great. Now let's look at the second part. In the second part, we have to check are A and C mutually exclusive. So we have to find the probability of A and C. So between A and C, here is A, here is C. Is there anything common between A and C? Between A and C, this is the time for you to speak
No.
up, look at
Nope.
it and tell me, is there anything common between A and C?
No.
No.
There is nothing common. So there are 0 common between A and C out of 10 elements. So 0 divided by 10 is equal to 0. So what we got is probability of these two events is 0. Okay, probability of A and C is 0. So we have seen that if the probability is 0, the events are mutually exclusive. So are A and B mutually exclusive?
Yes.
Yes.
Yes. So they are mutually exclusive. They are mutually exclusive. Okay. So this is the end of the addition rule of probability. Okay, we are going to work on the second rule for probability, and it's going to be the multiplication rule for probability. We have two multiplication rules for probability. We are going to start with the first part, and this is for the independent events. Multiplication rule can be used to find the probability of two events that occur in sequence. And when two events occur in sequence, we say that the events are independent or dependent. So first, we are going to look at the independent events. So meaning of that is, if the occurrence of one event does not affect the occurrence of the other, then we say that the events are independent. So when event A is occurring and it cannot affect the occurrence on the second, that is the independent event. For example, you are flipping a coin and also you are rolling a dice at the same time. So for example, you got head on the coin. So occurrence of head on the coin does not determine the occurrence of any number on the dice. So these two events are independent. And for the multiplication rule, we use the multiplication rule when you see the word and between two events. So if you see the word and between two events, then we use multiplication rule. Now, the multiplication rule for independent events is this one. Probability of A and B is equal to probability of A times probability of B. Please copy this formula. This is the probability of two events A and B which are independent. Now, we are going to take an example and we are going to look at the events. First, we are going to check whether they are independent or not. And if they are independent, we are going to use this formula to calculate the probability. Okay. Here is my example. So the problem says a bag consists of 8 red marbles, 7 blue marbles, 6 green marbles, and 4 yellow marbles. So like before, first we are going to find the total number of marbles here. So you can help me with this. The total number of marbles n is equal to, you have 8 red, 7 blue, 6 green, and 4 yellow. What is that equal to? Tell me what is the total number of marbles? Any idea?
25.
25, is that right?
Yes, sir.
Okay, 25. That is the total number of marbles that we have. Now, the question is, what is the probability of selecting a blue marble on the first try and then the green on the second try with replacement? So here, the events are occurring in sequence. So what we are doing is, we have 25 marbles in the bag. We are not looking at it. We just put the hand and pull the first marble. Okay, we have to find what is the probability of selecting the blue marble in the first. So you are pulling the first marble, you are looking at it, whether it's blue or not, you're calculating the probability that it will be blue. And what you're doing is, after that, you are placing that marble back in the bag so that the total number of marbles does not change. And then you are pulling the second marble. So we have to find what is the probability that the first marble is blue, and you can see there is the word and, the second marble is green. So we are calculating the probability that it is blue and then it is green. Now, for example, if you get blue on the first, do you think that it will affect what you will get in the second try? Because you are placing the marble back in the bag. What do you think? Time to speak. Anybody can unmute. So when you get a blue on the first, okay, and you place that back in the bag, do you think that what you get in the second is determined by what you got first?
No.
No. So that means these two events are independent. So if you remember the formula for independent event with n in the middle, it is probability of the first multiplied to probability of the second. Because we have and here, we have the multiplication sign. And is for multiplication. Now let's find this probability. Probability of blue, you can see there are 7 blue marbles out of 25. So 7 divided by 25 multiplied to green marble, you have 6 out of 25. 6 out of 25. So if you multiply, you are multiplying. When you multiply two fraction, you multiply straight across. So first you do 7 times 6, which is 42. And then in the denominator, you have 25 times 25, which is 625. So you can leave it like this as a reduced fraction, or you change this to decimal. So when you change this to decimal, you divide 42 by 625. Make sure you do it in your calculator and check it. I got 0.0672. Is that what you got?
Yes.
Okay. So what we have done here is we calculate the probability of blue and green. So these two are occurring at the same time. What is going on is after you take the first marble out to record your probability, you place it back. So before you pull the second marble, you are placing it back. That's why it says with replacement. Okay, with replacement. So the total number in the bag does not change. So when you pull it for the second time, you see that you still have 25 in the bag. Out of 25, there were 6 green. So these type of events are independent event. So we say independent event. Independent events because the occurrence of one does not affect the occurrence of the other. And the formula for calculating the probability of independent events A and B is probability of A times probability of B. Make sure you remember that formula. So that is the first multiplication rule for probability. Now we're going to look at the second multiplication rule. Okay, here is
Excuse
that
me, sir. I
second.
have a question.
Oh, okay. Let me go back. Yes.
Yeah, it's just an overall question. I joined the lecture a little bit late, and I didn't notice what was the keyword. Is there any keyword for multiplication? Because there was the
Yes.
keyword or and
Right. As I
for
mentioned here, the
addition.
keyword is and. Okay.
Yes.
For
Oh,
multiplication.
okay.
And in this problem, you can see there is and there. Do you see that?
All right, I see. So for addition, it's or, and for multiplication, it's and.
That's right. For addition
All right.
rule, it's or, and for multiplication, it's and. Very good
Thank
question.
you, sir.
Thank you for asking. Oh, hell no. Somebody is doing something there. Sorry about that. Okay, did you see something there?
Yeah, the phone call.
Yeah, it's interesting. Wow. Anyways, let's go to multiplication rule for probability part 2. And this is for the dependent events. Okay, this is for the dependent events. When I say dependent events, that is the occurrence of one event affects the occurrence of the second. Okay, so when two event or outcome of the occurrence of the first event affects the outcome or the occurrence of the second event, those type of events are called the dependent events. And in dependent event, the probability or the multiplication rule for probability will be this one. Probability of A and B is equal to probability of A multiplied to probability of B given A. So see, we have probability A and B, there is and, so multiplication, definitely. Probability of A times probability of B, but given A has already occurred. So that's how we write that. Probability of A and B is equal to probability of A times probability of B given A. That is the formula. Please copy that formula. Please copy that formula. Now let's take an example so that we understand about the dependent events, whatever events are dependent events, and how we can use formula to solve those problems. Here is that. Again, cards. I don't have all cards there. I just have a little card there, but in fact, they're all cards. I think I collected them together. Look at that. Okay, 2 cards are selected without replacing. Okay, there is something without replacing. What is the meaning of that? I want some of you to unmute yourself and tell me the meaning of without replacing. 2 cards are selected
on the
without
second.
replacing. Say that
You
again.
don't
On
put
the-
the first card in.
On the second draw, you're only going to have 51 cards.
Very good. So you draw the first card. When you're doing that, you have total of 52 cards here. But after you pull the first one, you are not placing it back. So your total cards in the second draw will be 51. And you know that the probability is the ratio of the outcome to the total number in the sample space. So your sample space is changing here. So as the sample space changes, the probability also changes. Meaning of that is, by pulling the first card and not placing back, you are affecting the probability of second draw. So those 2 events are independent or dependent? What do you think?
Dependent.
Dependent.
Very good. So the events are dependent events. So when 2 events are dependent, we have this formula. Probability of A and B is equal to probability of A multiplied to probability of B given A. When I write slash A, that is given A. So that is the formula. So we understand that the event here are dependent event. So we have to find the probability of selecting a queen first and then selecting a jack. So here we are looking for probability of selecting a queen and jack. There is and there. Okay, I wrote that and. Meaning of that is, it is the multiplication rule. And we know that it is without replacing, so dependent event. So our formula will be like this. So probability of the first, which is probability of Q, multiplied to probability of the second, probability of J, given Q. Like here we have probability of B given A. So probability of Jack given, it was already, the first one was already a queen. So now if I want to find this probability in the first draw, look here. When I pull the first card, what is the probability that it will be queen? That is equal to how many queen are there out of total cards. So how many queens are there out of total cards?
4.
4 queens. And what is the total number of cards?
52.
52. Sometimes that number will not be given there, but it's 52. Times, now, probability that it's a jack given the first is a queen. The card you pull is already a queen. Now, how many jack are still there in the deck?
4.
4 jack are still there. Out of how many cards?
52.
51.
51.
51.
Because you are not replacing, right? Without replacing. So you can see that the second probability depends on the first. The first one was 4 over 52. If we talk about all 52 cards, the second probability will also be 4 over 52. But the second probability depends on the first, so it becomes 4 over 51. That's why these 2 events are dependent events. Now, let's multiply this. First, what we do is 4 times 52. I mean, 4 times 4 from 4 over 52. How much is 4 times 4?
16.
16.
16. And in the denominator, you have 52 times 51. How much is 52 times 51?
2,652.
2,652. So that is the fraction. You can also change that to reduced fraction if you want. That is 16 divided by 2,652. You can divide both numerator and denominator by 4. If you divide this by 4, you will get a 4 there. And if you divide this number by 4, you should get 663. Make sure you check it. 2652 divided by 4 is 663. So that is the reduced fraction. You can leave your answer here as a reduced fraction or change it to decimal. So when you change it to decimal, you have to divide in your calculator 4 divided by 663. And what did you get?
0.0060.
0.0060.
60, that's right, up to 4 decimal places if you write. So 0.0060. So these type of events where you can see that the occurrence of the first event affects the occurrence of the second, those type of events are called the dependent events. Any question on this problem? No question? Okay. So what we have studied here is, so far we talk about the independent events and dependent events. If you are asked to check whether the events are independent or not, so if you remember, in case of independent event, if you can mute yourself, that'll be wonderful. Independent event, we saw that probability of A and B is equal to probability of A times probability of B, right? For dependent events, we saw that probability of A and B is equal to probability of A times probability of B given A. So these two rules are multiplication rules. Let me write that. Multiplication rules for probability. Sometimes they will give you two events A and B, and they will ask you to check whether they are independent or not. So if they ask you to check whether they are independent or not, you have to check this, whether probability of A and B is equal to probability of A times probability of B or not. So if probability of A and B is equal to probability of A times probability of B, then the events are independent. So make sure you note that point there. Two events A and B are independent if probability of A and B is equal to probability of A times probability of B. And we are going to use this rule and check whether the events are independent or not in next example. Okay. So here is that example. So let's work on these two examples. The first one, let's see what is given. Suppose probability of A is 0.40. Probability of B is equal to 0.80. We have to find the probability of A and B. I mean, probability of A and B is given. We have to check whether A and B are independent or not. One more time. Probability of A 0.40. Probability of B 0.80. Probability of A and B is 0.36. We have to check whether they are independent or not. So let me write here. If A and B are independent, you have already seen in the previous slide, if A and B are independent, then probability of A and B is equal to probability of A multiplied to probability of B. So let's check this. Here, if you want to find probability of A times probability of B, let's see what you will get. Probability of A is 0.40 times probability of B is 0.80. Okay, multiply this. What do you see? Please multiply those two numbers in your calculator and tell me what you'll get.
0.32.
0.32. So what we got is probability of A times probability of B is equal to 0.32. Is it equal to probability of A and B? Probability of A and B is 0.36. Are they equal? No. So this is not equal to probability of A and B. It is not equal to probability of A and B. It will be equal to probability of A and B if the result was 0.36. So probability of A times probability of B is not equal to probability of A and B. So are these two events A and B independent? If they are independent, those two values will be equal. They will be equal to sign. So what do you think? Do you think that event A and B are independent?
No.
No, they are not independent. So you'll say events A and B, events A and B are not independent. They are not independent. Any question on part A? Okay, look like there is no question. Now let's go to the second part. So here in the second part, suppose a balanced six-sided die is about to be rolled. So when you roll the die, the probabilities or the outcomes in the sample space are 1, 2, 3, 4, 5, 6. And we define the following events. There is event A, there is event B, and we have to find whether A and B are independent or not. So first, in order to check that, we need to find whether these two are equal or not. Probability of A and B is equal to probability of A and B or not. So first, what is probability of A and B? When I say and, we are looking for the common things. So what is common between A and B? Look at these two. Do you have any element common between A and B?
2.
2 is common. One element common out of 6. So that is probability of A and B. What is probability of A times B then? Let's find out. Probability of A times B is equal to, what is the probability of A? There are 2 elements in A out of 6, so that is 2 over 6. And then probability of B, in B you have 1, 2, 3, 4, 5 elements. 5 elements out of 6. Right? So probability of A times B, you have 2 out of 6, and probability of B is 5 out of 6. So if you multiply 2 times 5, 10 over 36. 10 over 36. Are these two values equal? Look at that. One is 1 over 6, the other one is 10 over 36. Are they equal?
No.
No, they are not equal. So if they are not equal, again, we get that they are not equal. In place of equal to sign, we get not equal to. So what we got here is probability of A and B. Probability of A and B is not equal to probability of A times probability of B. If we get not equal to, if we get equal to, they are independent. If we get not equal to, are they independent? Yes or no? The events are not independent. Okay, the events are not independent. So in both cases, in both parts, the events are not independent. If you have question, I'm going to take your questions now, if any. Okay. Look like you don't have question. So we work on 2 rules of probability. The first one was the addition rule, where we talk about mutually exclusive and mutually inclusive events. And this one is the multiplication rule, where we talk about independent and dependent events. In addition rule, there is or in the middle. And in case of multiplication rule, there is and in the middle. We have seen that. Now we are going to look at the third and the last type of probability from this chapter, and it is called the conditional probability. Okay, let's talk about conditional probability. The conditional probability of A given B. So here we are calculating the probability like this: probability of A given B. Okay, this is how we write. Is the probability of occurrence of A given that the B has already occurred. So this is like the dependent rule for multiplication. If you remember the dependent rule for multiplication, it was like this: probability of A and B is equal to probability of A times probability of B given A. It was like that. Now, if you divide this rule, if you divide this equation on both sides by probability of A, for example, if you divide by probability of A like this, what we'll get is on the right hand side, this get cancelled. And on the left side, we get probability of A and B divided by probability of B is equal to, here we have probability of B given A. Probability of B given A. So this formula that I obtained here, this is the formula for conditional probability. You can see here, if you are calculating the probability of B given A, always remember, it's quite easy to remember. if you are calculating the probability of B given A, in the numerator you have probability of A and B. In the numerator you have probability of these two, probability of A and B. And in the denominator you divide by the probability of the number after the slash. That is, you are dividing by the probability of A. Hold on. You are dividing by probability of B given A. See, I make a little mistake here when I copy that. This is probability of A. Hold on. Yes. So we divide by the probability of that, A. So remember here, when you have probability of B and A, you have B and A or A and B, which is same thing in the numerator, but you divide by the probability of this event, which is after the slash, probability of A. Or here you can see, if it is probability of A and B, it's other way around. This is B and A, this is A and B. In the numerator, you have probability of these two, A and B or B and A, however you write, that's okay. But in the denominator, you divide by the probability of the event after the slash, which is B, probability of B. Okay, so you need to remember this formula. Let's try one. For example, if you want to find the probability of X given Y, for example, if you want to find the probability of X given Y, help me write this formula. I want you to unmute yourself and tell me what I have to write in the numerator. Please tell me what we can write in numerator. Probability of X given Y. What
P,
will
X,
go in
and
numerator?
Y.
Yes, what is it?
P, X, and Y. P of X and Y.
Probability of X and Y. Very good. And in the denominator, what will go?
P of Y. P of Y.
Probability of Y. That is the event after the slash. Probability of Y. So you got it. This is how we write it. Okay. So this is the conditional probability. We are going to look at two important examples on the conditional probability. Okay, let me say that. This is the first example. You can see there are a lot of words there. We need to read first. We need to understand this. There are 100 birds in a zoo. 50 birds are male with brown eyes and 20 birds are female with brown eyes. That's one piece of information about the bird. In the second sentence here, 20 of the birds are male with blue eyes and 10 are female with the blue eyes. So what we are talking here is there are 100 birds. They are male and female, and some of the birds are blue-eyed and some of them are brown-eyed. That is what we can see from here. Now, what we are asked to do is we are asked to construct a contingency table. When we say contingency table, this is the table representing this information given here. So let's draw this table. What we are doing is we are looking at the blue-eyed bird and the brown-eyed bird. That's what we are looking at. And there are two types of birds. They are male and female. Is that right? This is what we have. Okay, you have male bird, you have female birds, you have blue-eyed bird, you have brown-eyed bird. Now we are going to fill this table. Okay, see, 50 birds are male with brown, male with brown eyes. So where do we put that? Male, okay, look here, 50 birds are male with brown eyes. Male with brown eyes, 50, so it will go here, 50. Did you get that?
Yeah.
Okay, male with brown eyes, 50. Next, we have 20 birds are female with brown eyes. Female with brown eyes, 20. It will go here. And then, in the second sentence, 20 birds are male with blue eyes. Male with blue eyes. It will go here. That's 20. Okay, and 10 are female with blue eyes. So female with blue eyes, 10 of them. It will go here in this box here, 10. So this table is the contingency table, but this is not yet complete table. What we have to do is we have to find the total. Okay, we have to find the total along the row. So if you add the first row, how much is 20 plus 50? Please unmute
70.
yourself. 70. Meaning of that is there are 70 male birds. That is the meaning. Okay. Now, if you add these, what you'll get? 10 plus 20 is how much?
30.
30. So that is 30 female birds. And if you add these 70 plus 30, that is 100 birds in all. Now let's add the other way around. If you add here, how much is 20 plus 10 here?
30.
30. So meaning of that is there are 30 blue-eyed birds. Okay. And if you add here, how much is 50 plus 20?
70.
70.
70 birds are brown-eyed. That is the meaning. So in either way you add these, like 70 plus 30 here or 30 plus 70 here, you'll get a total number of birds in the zoo, that is 100. So this table that we have created here, this is called, what is it called? The contingency table. Okay, so you must know how to represent the data in contingency table. In mastery exercise, you'll see a lot of problem where the information will be given in the form of contingency table, and you'll use that table to solve the problems. Now, let's solve the problem. What we have to do after that is, if a bird is selected at random, what is the probability that the bird is a female? Okay, bird is a female, given that it has brown eyes. So probability that it is a female given it has brown eyes. See, as soon as you see this one, given, female, given, brown. So whenever you see that word given, you are using the conditional probability. If you see or, addition rule. If you see and, multiplication rule. If you see given that, then you are using the conditional probability. So formula for conditional probability, if you remember, if you have something like this with slash in the numerator, it will be probability of these two. So probability that it is female and brown divided by probability that it is brown. Probability that it is brown. Now, from this table, I want you to speak up now. From this table, tell me how many birds are female and also they have brown eyes.
20. Right.
Female
20.
and also
30.
they have brown eyes, 20 out of 100. So 20 over 100. Probability, we have to divide by total. So 20 out of 100. Very good. Now, tell me how many birds are brown-eyed. Probability that it's brown. So how many birds are brown-eyed?
70.
70 out of 100. Very good. 70 out of 100. So when you simplify the complex fraction like this, see in the numerator you have the denominator 100. In the denominator there is also 100. So you can cancel those two hundreds. So you'll get 20 over 70 or 2 over 7. 20 over 70 or 2 over 7. So that is the answer as a reduced fraction. If you want to change that to decimal, you have to divide that and you should get 0.2857.
2857.
Very good. Thank you. 0.2857. Okay. That is the first part in the conditional probability. Let's go to the second part. In the second part, let's see what we are asked to find. We have to find the probability. Same question. If a bird is selected at random, what is the probability that the bird is a male? Bird is a male, given that, which is slash, okay? Male, given that it has blue eyes. So you'll write blue eyes like that. So you can see, because we have the slash there, this is the conditional probability, and the formula for conditional probability is probability of these two, M and blue, or male and blue, and we have to divide by probability of blue, right? Which is equal to, now, it is your time to speak up again. How many birds are male and they have blue eyes? Look at this
20.
table. How many
20.
birds? How many are there? Male and blue eyes, 20, right?
Yes.
Out of 100. And how many birds are blue-eyed? How
30.
many birds are blue-eyed? You can see
30.
here. 30 birds are blue-eyed. 30 out of 100. So 100 and 100 cancel. You'll get 20 over 30 or 2 over 3. Okay. which is equal to, you can change it to decimal. Tell me how much is 2 divided by 3.
0.66 continuing.
Yeah, 6667. Let me write up to 4 decimal places. So this is the first example on the conditional probability. By looking at the time remaining, I can see that we have 3 minutes remaining in this session. I'm going to end this session, okay, and then we'll come back. We have one more problem to solve here. It's also on conditional probability. Please don't go away. Wait for 10 minutes and come back. Okay, I'm going to end this session now.
Okay.
Is that good?
Yep.
Okay. So what we have seen in conditional probability is this. Let me write the formula. Conditional probability. We calculate the conditional probability of A given B, or given that the B has already occurred. In that case, we calculate the probability using the formula for this, which is equal to probability of these two. You can write A and B or B and A. Either way it works. So A and B. And we have to divide by the probability of the event, which is after the slash. After the slash, we have B. So it will be divided by probability of B. So that is what we have here. Now, let's read the question. Out of 46 selected group of students at a university, so they have selected 46 students in all, 24 are seniors, 28 are nursing major, and 6 are neither. They are neither the seniors nor the nursing major. Okay, that information is given to you. Now, the question is, if student is selected at random from that group, that's the group of 46 students, what is the probability that he or she is a senior given that the student is a nursing major? So let's write this. If a student is selected at random, what is the probability? So here we want the probability that he or she is a senior. I'm going to write senior like that. Senior, given that is a slash, given that the student is a nursing major. Okay, they are nursing major. We have to find this. So if I want to find this, we need to use the formula for conditional probability that says probability of these two, senior and nursing, the students who are both senior and nursing, divided by probability that they are nursing major, probability that they are nursing major. So that is the formula. Now, if you look at this, you can see here, probability that they are nursing major, it's given here. 28 are nursing major, 28 out of 46. I know this one, but there is no information about how many students are both seniors and nursing major. That is not given. So first we need to know this information. How many students are senior and also nursing major? So what I'm going to do is I'm going to draw a Venn diagram to represent this data. You can also copy this along with me. Let's draw the Venn diagram. As I told you earlier, if you draw a rectangle, that rectangle represents the sample space S, which is equal to 46 students in this case. And here we are talking about senior students and nursing students. So suppose this circle represents senior student and this one represents the nursing students. Okay, so they have given the information here. 6 of these 46 students are, they are not the nursing or not the senior. They are neither nursing nor senior. So those 6 students cannot be included in any of these circles. So you can put them outside the circle. What we are looking at is how many students are both senior and nursing. We don't know how many students are here in the middle. So let's consider that that is X. We don't know what is that. Okay, so the number of students who are both senior and nursing major, let's say they are X. Now let's go back here. There are 24 seniors. Now everybody, look at this one and try to answer my question. Unmute yourself. So there are 24 seniors. So in this circle, there are 24 students. Out of 24, here I have X. So how much will be here? Total in this circle is 24. Over here, we have X. What should be there?
24 minus
4
X.
minus X.
Very
minus X.
good. Look at you. You guys are very intelligent. 24 minus X. Very good. Now on the other side, here in nursing, there are 28 students. Out of 28 students, we have X here. So how many students are here then?
28 minus X.
28 minus X.
Wonderful. 28 minus X. But what we know is now, the meaning of this one, 24 minus X, they are just the senior. 28 minus X, they are just the nursing students. And this X, they are both nursing and senior. Okay. But if we add all these students, 24 minus X, this X in the middle, then 28 minus X, and then 6, which is there outside, what is that total equal to? Look at that. How many
46.
students are there? 46. So let me write that. We have to do a little bit of algebra there. 24 minus X, then that X in the middle, then 28 minus X, and that 6 will be equal to 46. Now let's solve this equation and find the value of X. You can see here is a negative X and a positive X. So those two will get canceled. Okay. Then let's add the numbers on the left-hand side. You have 24 plus 28 plus 6. Please add those numbers. You have 24, then 28, and then 6 on the left-hand side. So if you add these three numbers, what do you get? Is it 58?
Yes.
And then there is a minus X on the left-hand side, which is equal to 46 on the other side. Now, if I subtract 46 on both sides, if I subtract 46 here and subtract 46 here, let's see what we get. What is 58 minus 46? This one, 58 minus 46, that's 12. And there is minus X is still there, minus X equal to, how much is 46 minus 46?
0.
0. Now if I add X on both sides, if I add X on both sides, on the left hand side, X gets cancelled. So 12 is equal to, how much is 0 plus X?
X.
X. So what we got here is, there are 12 students. So this number in the middle, these 12 students are both senior and nursing. That's what we are looking here in order to use that formula. We didn't have that information. We did a little bit of algebra here and we got that information. Now you can plug in back. Let's do it. So now we can calculate that probability. Probability that the student is senior and also their nursing major is equal to. So this one here, senior and nursing major, there are 12. We just found that 12 out of 46. So you can do 12 over 46 divided by the nursing major. How many students are nursing major? It's given here, 28, right? 28 out of 46. So if you simplify this, 46, 46 cancel, you get 12 over 28. And you can reduce that by dividing both numerator and denominator by 4 here. 4 goes into 12 3 times. And 4 goes into 28 7 times. So your probability is 3 over 7. If you change it to decimal, what will you get? 3 over 7?
.4286.
Very good. 0.4286. That is the probability. So you can see this problem is a little challenging in conditional probability. It is just because this information is not given. Every piece of information is given, but they have not given how many students are both senior and nursing. So what we did is we check help of the Venn diagram. We did a little bit of algebra here. We got this reason, and then we use the formula. But the key here is whenever we are calculating the conditional probability, you will see given that. So in today's class, what we have done, we look at 3 rules for probability. The first one is addition rule. In addition rule, the key word is or. Second one was multiplication rule. In multiplication rule, the key word was and. And this is the third one. The key word is given that. So based on the information given in the problem, you have to use the right formula to calculate the probability. And this is the end of this chapter.